Okay, what we're going to do here is compare the external load for elbow flexion in a standing and a supine position. You can see the drawing here. So we're the person's standing and they're bending their elbow up. Here the person, they're lying and they're bending the elbow up. When the elbow is straight, it's 0 degrees, and when it's bent, it's 140. So here's our equation for understanding the external load. So we're going to do standing in red. Okay, and so essentially if we kind of think about this, we can kind of draw a free body diagram to visualize it. We have an elbow bent with a load at the end. So we'll draw the force of the load. This is the elbow's our axis point. And then this is straight, so that's 0, and then 140 is up here. So we know that the moment arm is the perpendicular distance from the axis to the load. So it's perpendicular to the line of action of the force. So this is really a long moment arm here, so we know there'll be a moment. And then if we straighten the elbow down here and we put the load right here, we can see that the load is really acting right through the axis, so the moment arm is 0. So we know that two things already. We know that when the elbow is fully extended in the standing position, that there is no external moment. So we can write 0 moment here. And then we know that essentially, because the arc of motion is going to be like this, and the moment arm is going to be, since every single time the load acts, it's going to act down, and the axis point is here, and the perpendicular distance to that vertical line is going to decrease as it flexes more or as it straightens more beyond 90. We know that the peak moment is occurring at 90 degrees, and so we can kind of come in here at 90, and we're going to put it there, but I got to erase this for a minute here. So we're going to get rid of that. We're going to put our peak moment here at 90. And then if we look at this some more, we know that pretty much the 140 degree point and the 45 degree point here are kind of this pretty similar, and they're in between these other 2 points. So we can go to 45 here, you can put something here, and then I'm going to erase this and put that right there. So then we've got a point here, and we've got a point here. And so then the moment looks like this. Okay, and now let's ask what direction it's acting. So as the person lifts up, the external load's acting down. So the moment created by the weight in the hand is to extend the elbow. And it's the same direction no matter whether we have it extended 90 degrees or 140. So this whole graph is for an external moment of elbow extension. Okay, so that's pretty good. Okay, so let's switch now to the supine position, and let's keep it Christmassy and go to a green color for that. So our shoulder, elbow, and hand, so I misspoke there a little. Okay, fully extended, and now we're gonna lift it up and come up to 140 this way. So something like that. Okay, so we've got the 90 degree position to consider. So this is the shoulder here. Okay, and then the 0. So we got 0, 90 here, and then 140. Okay, so we know that the load is acting down this way, so that's the force of the load. So we have that, and we have and then the same is here. So that's the force of the load there, and then we have the same here, and that's our force of the load there. Okay, so we can look at these 3 situations and then try to plot those. So what we can notice first is that we want to find the moment arm, because we have the lines of action of the force here acting down in each case. And so here's the axis point, because that's the elbow. So we know that the moment arm for 0 degrees is the perpendicular distance from here to the line of action. So that's a 90. So that's pretty long. And then we know here at 90 that the force is acting directly through the joint center. So we know at 90 that the force is 0, because there is no moment arm. And then we also know that this is the maximum distance that you can get for the forearm. at 90 degrees, and so we know this is the peak moment would be when the arm is at 0. So we'd know the peak load was here. And now something interesting happens. So we know that this torque, this external torque, is really acting just like it was when we're standing to extend the elbow. But what happens when we go past 90? Is the external torque still acting to extend the elbow? And the answer is no. So the torque is acting in this direction, so now it's acting to flex the elbow. So since this graph here is just graphing, the moment for elbow extension, it would look something like this, and then there would be no external extension load, it would be flexion. So that would be the answer.